to smash the like button and share this video with as many people as you can. And if you're not subscribed to my channel yet, kindly do it so that you don't miss any of my videos. So without any delay, let's get started. And today we are gonna learn about pointers in C. So today we are gonna learn about pointers in C. This is gonna be very interesting. So without any delay, let's get started. Damn! So over here, we are gonna learn about pointers in C. What is a pointer? Pointer is basically saves a memory address, right? It saves a memory address of it saves a memory address of where there will be a value of a specific data type that we have specified. So we'll just see it over here. So let's get started over here. We are including stdio.h, and we have int main that that will accept no parameters. It will return an integer value, so we are returning 0, and we have int a, so a normal variable we are creating. Then we have our int pointed to a, and this looks like a normal variable, but it isn't. We have a star over here. So this variable will save a memory location, right? A memory address. So this pointer to a will save a memory address where a integer data type value is saved. So this pointer to a variable will save a memory address where this data type, that is integer data type value will be saved, right? And then we're doing pointer to a equals and a. So what is and a? And a, because this and notation brings for us the memory address of a variable, right? So when you give and then a variable name, that will bring us the memory address of a variable that we can now save in our pointer variable, that is pointer to a. So in pointer to a, we are saving the memory address of a variable where an integer data type will is saved. So variable a has a type integer, so there an integer data type value will be saved. We are saying a equals to 5, and then we are printing the value of a is a, so 5. So a is 5, so we are printing that the value of a is 5. Then we are doing star pointer to a equals 6. So this is called dereferencing. Pointer to a is the memory address of a, right? It is pointing to the memory address where the value of a is saved. And when we do star, that brings the variable star pointer to a will dereference pointer to a, meaning that right now from a we were saving a's memory address in pointer to a. Now we are dereferencing over here, so we are saying that the memory address that is over here, in there the value should be changed to 6. So whatever value is saved in this memory address pointer to a, because of this star notation, we are saying change the value of that to 6, right? So whatever value is there in this pointer to a memory address, so whatever value is there in pointer to a in the memory address, right, that pointer to a is pointing to, there change the value to 6, right? So because of the star notation, we are able to dereference pointer to a and say that whatever memory address pointer to a is pointing to, there whichever value is saved, change that to 6. Then we are printing the value of a is so because a is pointing to this memory address that is saved in pointer to a, so a is pointing to the memory address that is saved in pointer to a, and that memory address value that was saved over there was we changed to 6. So immediately 6 a's value is changed because a was also pointing to the same memory address. So if there if over there the memory address changes, right? So if over there the memory address that contains a value changes to some other value, then a's value will be that new value, that is the change value in the memory address, because it is pointing to the same memory address, right? Because pointer to a is immediately the the is the memory address, right? In pointer to a, we have saved the memory address of a. So when we change the value in that memory address, so that is the memory address of a. So over there, whatever value we set over there will be the value of a. So that is 6. So now the value of a is 6, and then we print the value of pointer to a is, and this will bring us the memory address. So this will over here bring us our memory address, right? So this will bring us the memory address, it will show the memory address, what is the memory address of a, right? And then we are printing, it stores the value star pointer to a. So star dereferences pointer to a. So it so over here from star, this is bringing the value that is saved in the memory address. Pointer to a is the memory address of a, and star pointer to a is basically bringing the value that is there in that memory address, right? And over here star pointer to a equals 0 equals 6 was changing the value that was there in that memory address, right? And then we are printing the address of a is and a we have seen that it brings the memory address of a variable. So over here this and this will be same, because pointer to a is saving the memory address of a, and over here and a we are printing, so that is also the memory address of a. So these both values will be same. This will bring 6 over here because that is the value of there in this pointer to a memory address, right? And if we just run this, so we do gcc main.c, and then it's bringing some warnings, we can leave those, and then we do dot a dot out. Then we'll see the output. So the value of a first of all is 5. Then when we do star pointer to a, so this will basically change the value that of whatever value is saved in this pointer to a memory address, there it will change the value to 6. So a was pointing to that memory address, pointer to a is pointing to that memory address. So a is basically a's value is saved in the memory address. So basically a's value is saved in the same memory address the, as pointer to a is pointing to, right? Pointer to a is pointing to a memory address where a's value is saved. So when it changes the value over there um, to 6, then a's value also changes, so a's value is 6. The value of pointer to a is this, the memory address where the value of a is saved. So this is the memory address where our value of a is saved. It stores the value 6. So star pointer to a is dereferencing pointer to a. So star pointer to a is basically bringing the value that is there in that memory address, so that is 6. And the address of a is basically the same, where basically same as this, so wherever the value of a is saved. Quite cool. I think we devoted a lot of time on a single example. Let's see this example of pointers where we have int main, and this will accept no arguments and it will return an integer value that is 0. And we have int val, and then this is an integer. Then we have void star void pointer. So over here we are creating a void pointer, and this is basically saving the value of so this is basically saving the value of this is basically saving the memory address of our int val. So this is saving the memory address of int val, but this is a void pointer over here. So for void pointer, we can in void pointers, what we can do, we can basically so in void right. So over here, if you think about this, it makes quite sense over here. So what we do first, we initialize the void pointer vptr to point to an integer variable called int val, right? So first of all we do that in the first printf statement that is over here. right? What we are doing, we insert int star over here. We insert int star in front of our void pointer before we dereference, right? So we insert this int star before in front of our void pointer before we dereference it, right? Using our this star symbol, right? This casts void this basically casts a void pointer to an integer pointer. So this basically casts our void pointer to an integer pointer, and so the value of int val is printed as an integer. So the value of when we dereference it, the value of int val is printed as an integer, so the as it is value will be printed. In second printf statement, we insert char star in front of void pointer, right? So in front of void pointer before we dereference it. So in the second printf statement, we insert our char star in front of void pointer before we dereference it, right? This casts void pointer to a char pointer instead of a int pointer. It casts our void pointer to a char pointer, and so what's printed is the value of the character, right? So the value that is printed, so what is printed is the value of the character, which makes up the first byte of int val. So the last 8 bits, so the last when we cast it to basically when we cast it our void pointer as a character pointer, then it take this over here integers are saved in 4 bytes, that is 32 bits, right? 32 bits, so this is saved in 32 bits, right? But when we cast it to char, we can only have 1 byte, that is 8 bits. So it will take the last 8 bits, so the first 8 bits, basically the first 8 bits, so that is the first 8 bits of our value, this value. It will take the first 8 bits, that is the first byte of this value's binary number. So that will be 11, right? So that will be 11. If we just turn this decimal to binary, so if we go to a decimal to binary calculator, and then we give this decimal number and we say to convert it, so this is our number over here. So this, if we take these first 8 bits, 4 5 6 7 8, right? So these are the 8 bits. If I copy this from binary to decimal, and then we give over here, and then we say to convert, you'll see we'll get 11. So basically over here when we cast a pointer as an integer pointer and then we dereference it, then we'll get the exact value 25595 8283. But when we cast it to a character pointer and then dereference it, we'll get 11. It will take the first 8 bits of our number. So if we just run this, if we first do gcc main.c and then we do a.out, so then you can see that the value at a void pointer as an int is 255958283, and the value as void pointer as a character is 11. Quite cool. And let's move to the next example now. Comment this, and then we go to the next example. So now you must be thinking, why should I use pointers? Why should we use pointers if we can use normal variables? This is because these are very useful when we are using functions. So let's see how. Yeah, including std io.h, the header file, and then we have a int sum and difference method, right? But we have learned that we know that functions can return only one value, but we want to give, from a function we want to give our sum also and the difference also. How can we do that? We can do that using pointers. Over here we get int a we are accepting three arguments: int a, int b, and int star res. So res is for result. So over here it is accepting two integer variables, integer data type variables, and one pointer variable. It is accepting one pointer variable, that is result. So over here we have int sum. We are doing sum equals a plus b, and first we'll start from our main method. This will return an integer value, so we have returned 0. We have returned 0, and we have int b equals to 2 and int c equals b, right? So int c equals b, int b equals to 2, right? And then we're doing c equals to 3. So this is not needed, sorry. Okay, we have int b equals to 2, and then we have integer difference. So we have a difference variable. So in difference, our difference will be saved because we can't return two values from the function. So our difference will be saved in our difference variable, and our sum will be returned from the function. And what we are doing, we are printing the sum of 5 and %d is %d. If of 5 and %d is %d, so we are replacing of the first %d with b, the value of b, so that is 2. So the sum of 5 and 2 is %d. Second %d is replaced by the return value of sum and diff. So we are passing sum and diff 5, b, and diff, right? So we'll come back to and diff afterwards, but this is returning the sum of both of the numbers it gets, int a and b. So it will return 7 over here, this method, and that value, that is the value that will come as a replacement for our second %d. So over here it will show the sum of 5 and 2 is 7. But then what we are doing, let's now come to the interesting part. We are passing as a third parameter. We are saying we are passing the memory address of difference. So we are passing the memory address of difference that is saved in a pointer variable result, right? So that is saved in a pointer variable result, and we are passing the memory address of difference. And then what we are doing, we are dereferencing the memory address of difference over here. In first we are doing int sum equals a plus b, and we are returning sum. But before returning it, what we are doing, we are dereferencing our result. That is so over here difference is referring to a memory address. That memory address our function got. When it dereferences that memory address and sets a value in that memory address, the variable's address that was passed to our sum and difference, over there the value is changed. And because the variable that we passed is pointing to that memory address, that means that variable's value has been changed. It sounds very complicated. Let's break this up. So over here we have passed and diff. So the memory, let's take the memory address of difference as 123, though it isn't, but let's take it as that. So now this memory address 123 is saved in our result parameter. And then when we dereference our result variable, so that means that we are setting the value in this memory address. So we are setting the value in this memory address over here equals to a minus b. So whatever a we got, that was 5 and 2. So 5 minus 2 is 3. And that 3 value is saved in this memory address, in this memory location, right? So in this 1 to 3 memory location, in this we have saved, a minus 5, b, that is 3. So in this 1 to 3 memory address we have saved 3. But now this difference variable was also pointing to this 1, 2, 3 memory address where the value is 3. And this leads as the value of difference variable also changing. So this leads to the value of our difference variable also changing, that is outside our sum and diff method, but still because of pointers we are able to change it, and our sum and diff method is returning one value, and we are using it for two purposes, for a sum also and for a difference also. So outside the this difference variable was pointing to this memory location. So this difference variable's value was saved in this memory location 1 2 3, and there 1 2 3 whatever value was there in 1 2 3, we changed it in sum and diff to 3, right? There was no value over there, but in sum and diff we set over there as 3. So the value in 1 2 3 as 3, we set it over there as 3, and then it was set to 3. So diff's value is also changed because it is right after the like at the end of the day it is pointing to 1 2 3 only. So in 1 2 3 3 is saved, so diff's value is now 3. And when we print the difference of 5 and %d, so that is b, so 5 and 2 is difference, that is 3. So this is very very cool, guys. So this pointers is helping us a lot over here, and if we run this it should work, right? Oh, sorry. First we compile this and then we run it out. Sum of 5 and 2 is 7, and the difference of 5 and 2 is 3. So this was it, guys, for pointers. I hope you liked the video. If you did, don't forget to smash the like button and share this video with as many people as you can. Thank you, guys. Bye. Stay safe, stay healthy, and keep watching my videos. Then